Hello, second grade. It's so good to see you again. We have been doing all sorts of adding these two-digit numbers together. Gosh, it feels like so long since I've seen you, but since I've seen you last, we have done what? We've added tens to a number. We've added two-digit and one-digit numbers. And then we also use base 10 blocks to help us add these two-digit numbers together and started diving into these number lines. Well, today we're going to learn another strategy that's going to help us add two-digit numbers together. And we're going to use the strategies we've already used to help us learn how to do this one. And then tomorrow and the next day, we're going to have a chance to mash them all together and try lots of different ways. So hang with me. Let's go ahead and see our target, and then I'm going to connect what we've been doing with what we're getting ready to do. Ready? I can, let me hear you, add two-digit numbers together using partial sums. When we add them together, we're putting them together, right? So is our number going to be bigger or smaller than one of the parts that we're adding? That's right. They're going to be bigger. When we're putting them together, we're going to get a bigger number. Now, I say that, but let's think a little bit more about this. When we think about a two-digit number, what is a two-digit number? 52, 63, 99, 12. Those are all two-digit numbers, yes. So any number between 9, 10 is the next one, and 100, 99, are all two-digit numbers. And we could hit any of those numbers today, tomorrow, and the next day. But we're going to be adding those numbers together. So when we say two-digit numbers, what kind of digits do they have? Yes, they have. When we have a two-digit number, they have a tens digit and a ones digit. Absolutely. Do they have any hundreds? No, those are three-digit numbers. Okay, and when we say partial sums, does anybody know a word that sounds familiar? A sum is the answer to an addition problem. You're right. So guess what? When we think about that word partial sums, I don't know if you can see it, but inside of the word partial is the word part. And when we see that word part, that tells us that we're going to be chunking up these sums to help us add these numbers together. And I have to tell you, you guys have actually already done this. It's just looked a little different. So let me show you what I mean. A couple days ago, you started adding two-digit numbers together using base 10 blocks. Remember that? Seems like forever ago, doesn't it? Well, we were adding our numbers 25 and 23 together. And if you remember, we added our tens together first to get to 40. And then we added our ones and we got to 48. Again, we added our tens and then we added our ones and we got the sum. The first part of that we added together were the tens. 40 was our first sum. 8 was our second sum. And then we put them together. So the sum of our tens and the sum of our ones goes together to make our sum of our two-digit numbers. Sounds confusing? Not so bad. You guys have already been doing it. Same thing when we come over and we think about that 25 and 23 when we were doing our number line, right? Golly bum, it seems so long ago. Take a look. When we started with 25 and we added our tens, we're just chunking it up and making it easier to add. That's all we're doing today, friends. We still got the answer 48. Now we have different numbers today, but I think you're going to see some things that are very similar to the way they were last week. So let's take a peek at our first problem. 43 plus 25 equals, I don't know, our unknown. It's our sum, right? It's missing. So when we say that we can chunk this up and make it easier to add, I want you, and now guys, listen, you can use your tens and your ones to help you figure this out. You could use another tool to help you. You might just look at your tens and your ones. That's up to you. So whether you're at home or at school, I want you to think about what tools you want to use to help you solve this. And then we're going to pop them up here and make some connections to past learning. Go ahead and get started. I'm going to be listening in and talking to you about what you're doing, and then we're going to pop it up here on our board. Get started. What tool did you use? How do your tens and ones help you add this? How many tens are in 43? How many tens are in 25? Where are your ones? What did you add together first? And then what did you add together next? What did you add next? How did you find your total? So what was your first part? And your second part? And now your total? Remember, friends, that at any time, if you need to stop me and then start me again when you're ready to share, please feel free to do that. I'm seeing some friends doing some fantastic work, and I'd love to get it up here to show us so we can start thinking deeply about this work. Let's go ahead and start. Somebody was using their tens and their ones. Let's go ahead and pop that up here. Talk to me about what you drew. $43. Okay. And then what did you do? And how does that show 43? There's 4 tens, 10, 20, 30, 40, okay? And then 3 ones, 41, 42, 43, okay? And then what did you do? And where did you put your 25 when you were putting it up here on your work, or putting it in your journal? Why did you put it down here? So this friend just said that they wanted to see their tens and their ones together, and so they put them on top of each other to make it a little bit easier to see. Did anybody else do that? I'm seeing some wiggle waggles, and then some of you I see going, that's a good idea. Okay, what did you do next? Oh, I didn't put enough ones up there, did I? I need to put 5 ones up to make 25. 10, 20, 21, 22, 23, 24, 25. Good thing you caught that. What did you do next? And why did you circle up your tens? Because they're easier to add. I agree. They're so much easier to add when you add your tens together first. And what did you find? You had 6 tens. Okay, then what did you do? Oh, you knew that 5 and 3 makes 8. So you had 8 ones left. And so what did you say was the sum? 68. And how did you know that 68 was your sum? Where is the 60 coming from? So the 68 is really your 6 tens plus your 8 ones, and that makes 68. Awesome. Thank you for sharing your work. Okay, friend over here, talking about what you did. Ooh, that looks a little different than what this friend did. What did you use? Remember, gosh, it seems so long ago when we were writing an expanded form. Yes, this friend just said, I know that 40 plus 3 equals 43. Then what did you do? 20 plus 5 equals 25. Okay, what did you do next? You added your tens together. And so what did you add when you added your tens together? 40 and 20, and what does that equal? 60, and then what did you do? 3 and 5 makes 8, and then what? It makes 68. Hold on, second grade. Take a second for just a moment, and I want you to take a peek at these two pieces of work. How are they similar? How are these two ways similar? They did both add their tens together. They had their 4 tens and their 2 tens, or their 40 and their 20. And they both got 60. What else did they do that was similar? They add their 3 and their 5 to make 8, and their 1s to make 8. They both have the same sum. 68 is going to go in this blank. Now, guess what? This friend right here used base 10 models to show their thinking. This friend right here used partial sums. The first part was what? 60. What was the other part? 8. And then what was your total? 68. All we're doing is making it easier to add. We're adding one part and then the other part, and then we're putting those two parts together to find the total. Can I show you kind of a fun way that's another way, another add-on to show how you can do partial sums? It's kind of a cool way. So when we write an equation vertically, that means up and down. It's really tricky in the sense that we don't see them like that very often, right? So with this, we see this horizontally. That means it goes side to side. Well, my friend over here lined up her tens and her ones to make it easier to add when she was doing her base 10 blocks. We can do the same thing when we're doing partial sums. See how this person did it? Check this out. 43. Now we have our tens place and our ones place, right? When I write 25, I need to write my 2 and my 5 directly underneath of the tens and the ones that I wrote before. That's really important. You need to line them up. They need to be in the right place because it's easier to add, and otherwise we start losing our place and we get the wrong answer, and it's just bad news bears, okay? Tens and tens, ones and ones, and then we can put it all together. Then you're going to draw a line down here, and that represents kind of that equal sign, much like this one right here, okay? So this is saying 43 plus 25 equals what? Well, listen, we're still going to add our tens and our ones, and we're still going to partition it up, okay? So when we look at our tens, we have 4 tens and 2 tens. What is 4 tens and 2 tens worth? 6 tens. And what is 6 tens worth? 60. So I'm going to write my 60 right down here. 60 is the same as what? 6 tens. And how many ones? 0 ones. That's where that 0 is coming in. 6 tens and 0 ones makes the number 60. Now, what do you think I'm going to add next? Thumbs in front of your tummies when you think you can tell me. What am I going to add next? Yes, my ones. 3 and 5 makes 8. Now, this is still in my ones column, right? Zoop. Now, we can add those two together. 0 ones and 8 ones equals what? 6 tens and no tens equals what? And what do we have at the end? Ding, ding, ding. There's that 68. This is partial sums too. It's just another way to show it. Remember, I said at the beginning, when we're adding two-digit numbers using partial sums, we're breaking this big number up into parts. And by parts, we're going to break it up into tens and ones to make it easier to add. Let's see if we can put this to use with this problem. Are you ready? Okay. 35 and 26. Show me what you've got. Use those tools if you need them. How are you using place value to solve this problem? Remember that value is how much each of these places is worth. Like before, that 6 tens is worth 60, and that 8 ones is worth 8. That's that value of that place. How are you using that to help you solve this? Where is that 10 going to go? It looks like you're partitioning up more than once. Why are you doing that? There is another 10. Where is that other 10 coming from? How can you show that you're adding it together? How is this a good strategy to use? Is it faster than some of the other ways you've solved? Does it help you get the correct answer? We call that efficient. It's an efficient strategy. Okay, guys, we're going to come together and we're going to have you guys put your pencils down in 5, 4, 3, 2, 1, and done. I'm still going to share our base 10 block model because I really think that helps us make those connections to our partial sums. So with our problem before that, we did this first and then this. I want to do it again because I really want us to see where are these parts and how can we use what we already know to help us solve this, okay? So can I have my friend over here? Can you share with me what you drew? And why did you line it up the same way that this person did from the time before? It makes it a lot easier to see it, doesn't it? Makes it easier to circle it. So how did you show 35? Okay, 3 tens, 10, 20, 30. And how many ones? 1, 2, 3, 4, 5. Okay, and then what did you do? 10, 20, 21, 22, 23, 24, 25, 26. Okay, and then what? All right, you added those, and what did you find? 3 tens, there's 5 tens there, right? Yep, 3, and then 2 more is 5 tens. And you said that was 50. And how did you know that was 50? 5 tens is 50. How did you know? 10, 20, 30, 40, 50. Okay. And what did you do next? You knew that 5 and 5 was 10 and 1 more was 11. And so you wrote 11 ones. Okay. And what was your next step? Were you done? Why weren't you done? Oh. You added your 50 and then 10 more to get 60. Why did you break off that 10? There's a 10 and the 11, and it is easier to add those 10s first. So you were really grouping those up, and there's that 10 more. Okay, and then what else did you still need to add? So you need to add that 1 more. And what did that equal? 60 plus 1 is 61. Does everybody see what this friend did? Did anybody solve it the same way? Okay, seeing a lot of wiggle waggles. Okay, I have a friend over here that was using their partial sums. How did that partial sums look when you were solving it? How did you show 35 when you were doing your partial sums? 30 and 5. Yeah, looks really familiar, doesn't it? 30 and 5, yes. How did you show 26? 20 and 6. And then what did you do? You 30 and 20 was 50 because 3 10s and 2 10s is 5 10s. And then you had 11. And then what did you do after that? So you didn't just find your sum either. You said 50 plus 10 equals 60. 60 plus 1 equals 61. And what number did you decompose when you were trying to get to 61? Remember, decompose means to break it up. You broke up that 11? Yes. So what did you break your 11 up into? And why did you break it up into 10 and 1? Adding those 10s together again. What are you noticing we're doing every time that we're adding these numbers together? We're adding our 10s together first. Friends, I have to ask you, how is this partial sums? What makes it an efficient strategy? We were talking about that one of the last times we were together. And we talked about that idea of an efficient strategy being a strategy that is quick and it's accurate. What makes this one quick and accurate? You're adding your 10s and your 1s, and then you're adding them together. It's easy to see, isn't it? As we keep working tomorrow and the next day, we're going to be combining all of our ways, including the base 10, the partial sums, and we might even see some of those number lines pop back up the next 2 days. Remember, when you're solving these 2-digit numbers, look for those 10s and those 1s and see if you can start pushing yourself to writing those equations and get away from those. These are still fantastic, aren't they? But it's more efficient if we can do it that way. Oh, happy solving, friends. I'm excited to see what all you do in the next couple days.